Thank you, Brian. And thanks everyone for joining this session. I know it's the last session of the 3 days event. So hope you guys all enjoy it. And I will try now to bore you guys and share you some exciting stuff. I'm currently working, oh no, it shouldn't be here. Yeah, since it's already this page, I will talk a little bit about myself. So my name is Jing Pan. I'm a data scientist with over 5 years industry experience. I'm currently working for Uber and also actively contribute to the open source package CausalML, which I probably will talk about today. I also worked for FabFitFun and Teleflower on the marketing data science team. Also, another thing, it's my 5th year at DataCon LA. So from 2016 September, I participated as a volunteer. As you can see, I still have this T-shirt at my home. So I made so many good friends and attend every single one from 2016. So 5 years later, here I am. I'm glad I'm able to share back with this great community what I'm currently being working on. Okay, so this is today's agenda. I will talk about the traditional models have been used for marketing and why that's not efficient, why uplift modeling might be a better choice for you. What is uplift modeling and what's the algorithms available in this causal ML package, and also a real use case at Uber. Okay, so as you can see, this chart probably shows you how data science or machine learning applied in every single part of the marketing cycle. So acquisition of lookalike model to acquire more customers and driven user to sign up. Purchase or propensity or response model to help increase the user's purchase frequency. Also cross-sell or upsell model or even recommender systems to driven the users across different products on the platform. Churn or win-back models for the customers who at risk and haven't purchased for a while. Also, usually the marketing mixed modeling to use for optimizing the marketing spend. So it all looks great. Why I'm saying it's not very efficient and why there's been a gap. So whenever you started to building a model, you need to know what the business need. So if without that, it will always be very dangerous. So we often see a mismatch between the model and also the business problem. So as I listed here, those are probably the typical models all the data scientists are currently building, like propensity model, churn model, response model. But why this is not the real business problems that marketers try to solve? So for example, the holiday season is coming. All the marketers want to drive more sales and came to you to say, hey, I want to drive more sales during this holiday season. Can you help me with your machine learning magic? Then you are very excited and said, yes, I can build a propensity model for you to predict who with a higher probability to purchase for this upcoming holiday. Then what? You build the model and return the customer list to the marketer and suggest maybe they can do the marketing campaigns on those customers with higher than 80% propensity. And also your model is extremely good. You with AUC score around 0.8 or 0.9. This is what usually happened during my past 5 years working with the marketers. Well, unfortunately, this actually not the business problems we hope to solve. To drive more sales, marketers probably want to know who are the customers with the higher propensity to buy with the marketing campaign, all those who are like more discount sensitive customers without the marketing campaign intervention, actually their propensity is lower. If you are a little bit confused for this logic here, don't worry. I will break down the problem into more details. So again, for this propensity model you already built, you recommend the high propensity customers here. So for those customers, we actually can break them into 3 groups. So first group, here, they will only purchase if because of the marketing campaign, which is gonna be our ideal audience here. Second group, those probably loyalty customers, they will purchase regardless. So here, if we are sending promotion or marketing campaigns to them, which will be the cost we actually wasted here because they're gonna purchase regardless. And the third group, probably the worst case here. They might hate emails or social media ads because all the marketing campaigns, oh, sorry, marketing campaigns, um, because of you send them this marketing campaign, actually they decided not to buy. So here we not only waste the marketing cost, but actually lost the revenue. So here, go back to the main business question, what we are care about. So what we actually care about to maximize the profit, to increase the revenue and save the cost, which means we care about more about the incremental value. Let's look at another thing typical marketing data scientists or analytics usually do during the work, which is A/B testing. A/B testing is great. We usually run an A/B test and it will tell us which one actually performs the best among control and the test. So usually what we do, we use the standard, we use the average treatment effect as an evaluation metric to measure which one is better. If the control wins, we're gonna serve the control product to all customers. If the test wins, we're probably gonna serve the test product to all customers. But here actually we are wasting and we are lost the opportunity actually to personalize the experience or the campaigns for individual customers. So for the 2 main issues I described, what can help us, then how? Uplift modeling here actually can help. So first, uplift modeling actually optimizing the incremental effect, which is the delta between which is the delta of with and without intervention. So you will know the incremental effect of your marketing campaign. Also, because uplift modeling can actually estimate the conditional average treatment effect on user level, this will enable you to launch the personalized experience for the customers. Okay, so what actually is uplift modeling? Uplift model actually estimates the heterogeneous treatment effect using machine learning algorithms. Conditional average treatment effect here, CATE, actually is the expected value of with intervention minus the expected value without intervention. So this way you get your incremental treatment effect. This can work for both treatment level or user level. Okay, yeah, let's look at this chart, which probably is the most famous chart for uplift modeling. So the x-axis here is the customer, whether they're gonna buy if not treated. Y-axis here is buy if treated. So our goal actually here is to find the persuadable users, which they won't buy if they not given a marketing campaign, but they will buy because of the intervention. Also, we don't want to waste money on sure things and lost causes, because no matter what, they won't change their behavior. And also, we try not to spam those sleeping dogs, which as the users are turned off by your intervention. So definitely don't include them. Okay, to a high-level summary, what are the use cases for uplift modeling? First, targeting promo spend. We can use uplift modeling to target the users which will have a higher incremental value, and also stop stop like spamming users who potentially have a negative treatment effect from your marketing campaign. Also, it can help you uncover the effects. Even if your overall treatment effect or the overall marketing experiment is neutral, we still can use uplift modeling to identify the subgroups that have the positive treatment effects. So that's uplift modeling. And what are the available algorithms available right now for uplift modeling or causal inference? So the folks at Uber, we developed this open source Python package called CausalML. We, oh, sorry, we including most common used are also the cutting edge algorithms in the causal inference and uplift modeling area. So it included 4 different kinds of uplift models, uplift trees, Metalearners, neural networks, and instrumental variables. Overall, it included around 11 different algorithms. Not only all the different algorithms, we also have all the support functions available here, all the way from data generation, visualization, feature engineering, feature importance plot, propensity score matching, and also sensitivity analysis. Down here, I will have a little bit of details about the algorithms. So the most popular algorithms I have been used during my work is Metalearners. So here is an overall, like an overview of the Metalearners family. This tells you how the different algorithms works. But due to the limited time we have today, I won't go into the details of each learners, but I do want to share you about the most simple one, S learner, to let you have an idea what this, all the different meta learners, how this works. So first, with your data set you have, no matter it's experimental data or observational data, you can like generate a binary feature is treatment here, indicate whether the user is from a treatment group and all the control group. So here you train a single model. After you have this single model for all the users, you set this binary flag is treatment to 1 and calculate the predictions here. Similarly, you set the is treatment to 0 to calculate the control treatment effect. So here we're using the treatment effect minus the control in the control group treatment effect. So here we can get the Kate, which is our conditional average treatment effect. I have all the slides here available for T learner, X learner, and R learner. Feel free to take a look how the different algorithms works, and also in our GitHub page, it have very detailed explanation as well. Okay, so once you have the uplift modeling, what's the way, how could you use it? So this is a chart about like plot the percentage of the population target versus the cumulative uplift. So as you can see here, if it's random, you will target 100% of the user and your cumulative uplift will be 0. This chart called area under uplift curve. For example, if you have this X learner model built, you can achieve 40% of the uplift only to target about the 10% of the user. So it's gonna be a huge save of your marketing spend. Similarly here, those are probably the sleeping dogs, which will have the negative, actually have the negative incremental impact. You probably want to stop spamming those customers. And here again, those users with the highest uplift, you probably want to offer them promos to those customers. Okay, with a data scientist, as a data scientist, you probably also want to know what actually causing the uplift here. So within the CausalML, the Python package, we do provide the visualization about all the different feature importance rankings. So here is an example. We integrate with the Sharp package. Actually, it will generate for you for each individual features, what's the positive impact and what's the negative impact. And also here, this is a dependence plot. You can generate for each different features and versus different features. So this will tell you the story, what actually causing the lift and what actually driven the incremental values for the marketing campaign. Also, again, within this CausalML package, we also provide the visualization for the tree-based algorithms if you are going to use it. A key part also for uplift modeling is to do the evaluation. After you build the model, you want to know how accurate your model is. So here we provide three ways for you to do the evaluation, experimentation. You can compare your model your model's output with the experiments results. And also you can run a couple different Metalearners uplift traits to compare the model results to check if they can perform consistently. Again, we provide the different synthetic data generation process, which include the true labels, the treatment effects. This allows you to measure the accuracy on Kate, which you can use the synthetic data to do the evaluation. Okay, next, sensitive analysis. Sensitivity analysis is a way to test the robustness of your model performance. We provide a couple different methods here, placebo treatment, second, replace or add irrelevant confounder or subset validation, all the different ways for you to generate the sensitivity analysis. Okay, a real example case, what I've been working on at Uber. Uber Bidder, which is our in-house real-time bidding engine. It's targeting millions of users worldwide today. We are live in 5 mega regions across 11 countries. It covers over 20 million users, and we bid on 10 seconds ads, 10K ads every second. So what we typically are using is a propensity model to predict the user's propensity, whether they're gonna take a Uber trip or purchase a Uber Eats order in next 7 days or 14 days. So our team being able to replace the propensity model by the uplift model, and we achieve the much better actually marketing performance. So this is the design of our campaign. How could we automate the whole campaign performance? So we split our audience to 3 different groups. So first, holdout and exploit and explore. So the main purpose here, holdout group, is to measure our campaign performance. We are using explore group, which is around 10% of our data, actually to build the uplift model. Then we feed our model and replace it every month to generate the uplift scores on the exploit group. So and we will reshuffle this automatically every month. So we build uplift modeling with the new data every month and relaunch it monthly. Okay, so this is the campaign results with a real campaign we have. You can see from this uplift curve chart here, we are able to achieve over 100% of our original campaign incremental values, we're only targeting 50% of the original population by identifying the persuadable users, which is a huge save for our marketing spend. Well, there are always a lot of discussions, people talking about how could we compare the results between propensity model and the uplift model. So here is from a real case of our campaign. We plot the uplift score versus the propensity score. As you can see, the score are weakly negatively correlated, which means even though like a propensity score model is very easy to build in general, but it cannot substitute the uplift model because the two scores actually not like very correlated each other. I think this is pretty much all I want to cover today. If you haven't heard about uplift modeling or causal inference, please check out our GitHub page, try to install and play around with this package. We do have a couple awesome example notebooks there. Also, if you are interested in this area and you are like you are very familiar with the causal inference, we very welcome all the people to contribute to this project. Yeah, I think that's it. Do we have any questions?
Well, that was absolutely awesome. Thanks again for making the presentation. And we do have one question. I don't know if you have your WOVA in front of you, but Anthony Sledge asks, how are you able to determine if someone will buy no matter if they see ads or not? My first thought is Coca-Cola, who advertises no matter what. How are you sure that this branding isn't working?
How are you sure that this branding isn't working? To determine. Sorry, I'm trying to understand this question. So basically, you are asking whether the uplift modeling can generate the incremental values, or whether someone will buy no matter if they see ads or not. Okay, my first thought is Coca-Cola, no matter what. Yes. This is a great question. So first of all the things I think I've been working on during marketing data science is that without the testing, you won't know the result. You probably need to launch the experiment first to test whether this branding or campaign works or not. So after you have this like an experiment launch, you gather the results, you can further using the data to help you build this uplift modeling to tell you like what kind of people actually have a higher incremental value. Also, as I shared within the slides, even though sometimes your overall campaign results is neutral, you didn't see any incremental values for your whole campaign, but with uplift modeling, you still can like find out the subgroups which will have a higher incremental values as a return. So that's the benefit, that's the beauty of the uplift modeling. Okay.
Good. And as we move, we do have another question from Harold Huggins. Pan, what UI tools do you recommend to aggregate analytical data to a graphic display?
What UI tool? So I'm currently using Python very often. So during my day-to-day job, I usually using Python, but I know there are probably a lot of great analytics tools available, like Looker or like Tableau. Yeah, feel free to check out those things. But for me, it's mainly Python recently.
And then from Ansel Tang, similar to the other question, how do you know if someone will be turned off if receiving a promotion? Specifically, how do you tell
So that's a great question. So for one customer or one user, whenever you did anything, you you only know their response, right? You during this word, for example, I send a promotion to this person, Tiffany. I only get the feedback whether she buy or not. We won't know if we don't send the marketing campaign how Tiffany gonna respond. So that's also the benefit of using the causal inference framework. During the treatment and the control group, we tried to find the similar customers as Tiffany, probably who haven't received the marketing campaign. We will understand what's their performance, what's their return. For example, there are two more customers with very similar, like all the similar features as Tiffany
Hmm.
does, who actually don't buy our product because we don't send their marketing campaign. So we will know, oh, okay, actually this works for Tiffany, vice versa. If there are some people, users, actually after we send the marketing campaign, they didn't purchase, but in our control group, we find similar users, they actually will buy without the intervention. We will know, okay, those person actually turned off by the marketing campaign. So that's the way how we understand and to generate the heterogeneous treatment effect.
Okay, and I guess that's from my own personal knowledge here, because I feel like everybody keeps swimming in the same field of questions. Um, you guys actually create a profile of the group before you actually send out your campaign to them, so that you know what they're most susceptible to. Because
Mm,
I think everyone is asking the question of, if you send a campaign to someone and they do not respond, how do you know that they're not responding because they don't like the campaign, or they're not responding because it's not the right campaign for them? Does that make
uh,
sense?
I think that's a good question, but I think that's not the purpose of the what the uplift modeling try to difference actually, because um how to explain this, because if a user didn't respond to your marketing campaign, right, uh so you won't have any like a revenue impact generated by those users. uh for us, the uplift modeling here is to find which are the users will respond to the marketing campaign, actually will respond with a higher incremental value return. So here we are not to distinguish whether they didn't respond because they won't buy or they don't like the campaign. I think maybe that's like another more more questions for other things to solve. Yeah.
Okay, makes sense.
Mhm.
And we have another question from Scott Edwards. This is super interesting. Thank you. Where can we obtain the slides, and do you recommend any references for learning more details about this technique?
Yeah, for sure. I will definitely share the slides with you guys. And also, I don't remember the full name of the course, but there do have a course on Coursera. It's called the Crash Course for Causal Inference. It's not the similar ideas of what we've been using, like the Metalearner algorithms applied in my day-to-day job, but it will give you a very great introduction about causal inference, about what's the propensity score matching, all the fundamental questions about this area. Yeah, I highly recommend that course. And also a lot of team members within Uber, they also took the course, and they have very good like a recommendation for it as well.
And the last question is, I suppose, is right along the lines of the previous question, which is this published somewhere?
Yes, I will share the slides with you guys. And also feel free to check out our GitHub page, CausalML. It will including all the like the reference of the paper, everything will be available over there as well.
And that concludes the list of questions that we had. Let's just, I suppose we can give it a few more minutes to see if anybody comes up with any last minute questions.
Okay,
And
sure.
if you have anything that you wanted to share with the group before you depart.
I think this data con LA is definitely very interesting journey for me. As I shared before, I started as a volunteer to this conference. Then I'm being like able to actively working on the data science related projects. And luckily, I'm being involved in this very cutting edge causal inference area. So I do really enjoyed the whole journey, and hope everyone can like participate next year. Hope you can learn something, and also you can like share with the community next year. Yeah, that's it. Yeah, I think that's all I have for today. And thank you guys for joining my session. It's the last session of the last day, and also it's a Sunday. So I hope I can give you guys a couple minutes back and enjoy your night.
Jing, thanks a lot for your presentation. Thanks for your time, and thanks for presenting at DataCon LA 2020. We really appreciate your
Mhm.
knowledge base and again your time, you know, to taking out of your weekend.
Okay, sure. Yeah, thank you guys. Bye. Have a great weekend.